This is the first features now. And then what you can do, you can say, well, let's give me a histogram distributions of these data sets here. And how do you do that? You can use a plotting function called a hist in the matplotlib. And then you hist here will give you the histogram here. And let's say I want to use bins, number of bins. Let's say use 10 bins to plot the histogram. And that will give you the overall histogram on the values of the first features. And then let's give you a rough idea. What rough idea is this? Well, and I know that this first features is distributed roughly between 4 and 8 here. This is the range of the values. And then you say, well, roughly follows this type of a, now, can I say a bell-shaped distribution? Right? It's not multimodal, it seems like only one mode here. And then with mean value roughly at 6.0, maybe slightly less. And then with the dispersion between 1 or 2 values. And this is the first features here. Well, you can look at the other features. Let's look at the second feature. And that gives you a distant histogram of that. So now you can clearly see that what data sets here, distributions are, a range of values are different between 2 to 4.5 here. Let's look at the second one. That will be, well, this will be a different observation. Now I do see a bimodal distribution here, and with some data sets located between 1 or 2 and so on. And let's look at the third ones here. And this one is also showing kind of a distribution clearly different from the first 2 features. And that gives you a rough idea, say, what does the data look like? And then based on the so-called histograms of these data sets here. Say a histogram. And you can see the histogram very easily using the plot hist libraries. All right, so the next plot I kind of mentioned in the lecture is something called a scatter plot. Right, the scatter plot is plot one feature against the others. So that's called a scatter plot. So let's do that. Suppose I want to plot, so here histogram will only give you a visualization of one feature. And suppose I want to see 2 features at the same time, and how to do that? Well, that becomes harder because you have two-dimensional features. And to do that, usually I will do a scatter plot. I just plot one values, maybe do a scatter of x0 against the second feature, x1 here. Let's do that. Well, this will give you a scatter plot of the first 2 features. And this is the first feature, x-axis is the first feature. The y-axis is the second feature. Each dot represents one sample. And that will be this distribution will look like. We'll say, well, this is what's look like here. For all the 150 samples here, roughly the distribution looks something like this. And what do you see from here? Well, I see from here it seems like there are 2 groups here. There's one group here, another group here. Right, let's look at other type of a scatter plot. Let's say instead of a first feature versus second, let's do a 0 versus 2. Well, this gives you a different scatter plot. And this one here, I think is going to be meaningful because maybe in the previous one, you may argue that the pattern is not so clear, but this one is pretty clear. And you can see clearly there are 2 groups of features here, one here, the other one's here. Well, and now you may start to ask yourself here, you may wonder, and in this case here, I want to solve this classification problem. I want to predict the labels of each samples here. But here, even though I have not seen the labels yet, I only plot the features. Well, I wonder, maybe this group data set is associated with one class label, maybe associated with a different class label. Maybe that's the case. And this is you might have a working hypothesis and look like this. I mean, if this is the case, well, and you might think that it'll be easy to predict labels because I just put a boundary here, and this dot I predict with one label, the other dot I predict another label. Well, so this is your working hypothesis. And how to verify this? Well, let's do this. Let's put the labels on top of this data sets here. Let's put that so that I can visualize them. Well, how to do that? Well, maybe I can use color to represent different class to represent labels here. So let's try to do this one here. So this is a scatter plot here. But now, maybe let's do this. Maybe I'm gonna not scatter plot here. Let me do just do plot here. In fact, you can do plot, achieve the same results here. I'm gonna use plot here, dot blue here to represent this data set here. So this is my dot here. Now, what I'm gonna do, sorry, let me actually make the, I don't know if you can see it. Let me actually make the figure bigger. Okay, so too big maybe. You can see it. Too big. You can change the size of your figure. Okay. Maybe 8 by 8 is good, right? This is represent the first feature, and this represent the second feature. So now include all the dots here. But now suppose I want to only look at this data set with labeled with first classes. And how to do that? I have y here. I say I want to identify y with first labels here. Y equal to 0. So let's do that. So I want to plot another x here. So now, maybe y equal to 0. Okay, let's see if I can do that. I'm not sure if I can do that. Y equals 0. Two here. And I plot with the red dots here, if I can do that. Okay, see, that's came out here. So what I did here is this. So previously, let me use a different label. Right. So here, what I have here, I have this dot here, included all the data set. But suppose I want to only plot data with labeled with the first class with y equal to 0, and then select a subset of them with y equal to 0, and then do the scatter plot again. And what you can see here is this: the first classes, the sample associated with label 0 are all located in this region here. And those dots here are labeled with 1 or 2. So by doing that, so that gives you confirm your working hypothesis. Say, well, they are actually separate. The reason they are separate because they belong to different class of flowers, different types of flowers. And then if this is the case, and you know that, to predict the labels will become relatively easy because you can draw a boundary, and in this two-dimensional plot here, you can relatively separate these two classes here. However, right now it still didn't address the problem. How do I predict the labels of 3 classes? Because what you can see here only say, you can separate label 0 from the rest of the 2 labels, label 1 and 2. But these 2 are still seems like mixed together and you need to separate them. Well, so right now you only use the first feature and the last feature. Maybe you can utilize the second feature and the fourth feature to help you to further separate them here.